Bismillahirrahmanirrahim. Assalamu alaikum dear students. I'm Arif and I welcome you all in today's session. To access the notebook for today's session, you can access course page on my personal website arifbhat.me. You can click the appropriate notebook link under the lecture resource column to view it in Jupyter NB Viewer and can run it online in Binder. The other way to download it from the course GitHub account Arif PUCIT, and here is the public data science repository. This is the Jupyter Notebook dashboard running locally on my machine at port 8888, and here is the notebook for lecture 2.12 of the second module, Basic Python Programming, for the course titled Tools and Techniques for Data Science. My dear students, today's session is a continuation of previous session in which I introduced the concept of functions in programming languages, which are a group of related statements with a name that help break our program into modules, avoid repetition, and allows reusability of code. We also learned to write user-defined functions using this def keyword. We also discussed and practically saw examples related to required arguments, positional, default, named, variable length, and arbitrary keyword arguments. We also saw how we can pass command line arguments to a Python script. We learned by examples the difference between passing arguments by value and by reference. And finally, we practically understood the difference between local, enclosing, global, and built-in scopes, the four scopes, as well as the use of global and non-local keywords in Python. My dear students, if you have not watched that session, I strongly recommend that you should watch that first and then fall back to this for better understanding. And here is the agenda for today's session. We will start with writing Python Lambda functions and how we can pass a Lambda function as an argument to other functions. We will then study the famous map, filter, reduce, and sorted functions, as they all receive a function as one of their arguments. We will see how we can pass Lambda functions to these functions, instead of passing a regular named function. Finally, in the bonus part, the Python zip function and the concept of iterators and generators will be discussed. Okay, we have a lot to do today, so let's start playing. We begin with understanding a Lambda function in Python. My dear students, this pink box contains the definition of a standard Python function that is passed one argument and it returns its square. In Python, a Lambda function is a function that is defined without a name. Let us compare our regular function definition with our Lambda definition. The first notable difference is instead of using this def keyword to define a regular function, we use a Lambda keyword to define a Lambda or anonymous function. Second difference is, in case of a Lambda function, there is no function name. That is why it is called anonymous function. Third difference is the comma separated arguments to regular functions are normally enclosed in parentheses, while in case of the Lambda function, over here we have just one argument, but if there are more, they will be comma separated but are not enclosed in parentheses. After the colon over here, in case of a regular function, we have one or more statements whereas a lambda function can have an expression only, an expression that returns a single value. A regular function may or may not have a return value, whereas lambda function will always return the result of this expression, and that too without the return keyword. The sixth difference is lambda functions cannot access variables outside their local namespace, that is, cannot access global variables. My dear students, Python functions can be used as first class objects. So you can assign them to variables. As you can see over here, we have created this lambda function and assigned it to identifier. So this is the address of this lambda function, which will come up in this identifier named scare. And below that, I have used this name to call the anonymous function with the value of 5. Other than assigning a lambda function to identifier, you can pass a lambda function as argument to other function, and you can return a lambda function from other functions as well. Enough of theory. Let us now make our hands dirty and transform some regular functions to lambda functions to have a clear understanding. Okay, so this is a function named scare1, a regular Python function which is passed one argument, and it computes the power of this value, power of 2, that is, it scares this number and returns that result. And over here I have called this function with a value of 5. So this is what we have done in the previous session. Let's try to shrink this function a bit. Instead of writing 2 lines as over here, we can write it in 1 line. We just say return num power 2 and we can execute it. Although not a good programming style, however, we can write this in a single line as well, like this. And it will again work fine. Now this is the form of this function with a lambda expression. So we use the lambda keyword instead of def. Then we have the argument without the brackets. And after the colon, instead of coming to the next line, we just write down an expression over here. So this is the expression which will be returned by this lambda function. So it returns an address of this lambda function. We can receive this address inside an identifier. And if we print this identifier, you will see the address of the lambda function. And of course, the type of it is function. And over here, I have called this lambda function with a value of 5. My dear students, this is just for understanding. Normally, we do not assign the lambda function address to an identifier and later use it with a name. This was just for understanding. Let's suppose that we have this regular function and we want to transform it to a lambda function, a function that is passed 2 arguments and it returns the sum. So this is the corresponding lambda function. We have the keyword lambda. These are the 2 arguments that are passed, comma separated 2 arguments without parentheses, and after the colon, here is the expression. So we are receiving this return value in an identifier and we are calling it with 2 values. Let's see another example. Over here, we want to transform this function that receives 3 arguments and return their sum. So I hope this makes sense to you now. We have 3 arguments and this is the expression which will be returned when this lambda function is called. And remember, the return type of this corresponds to whatever this expression has generated. Over here it has generated a floating point value. Uh, and this is a function, lambda function, that is receiving one argument, and it returns true if this number is an even number, and it returns false if it is an odd number. Okay, another example, a lambda function that is passed a string, and it just returns the first character of that string. So once this will be called with the string hello, it will return H. I'm just having a lot of examples so that you should have a fair understanding. So this is again a function, anonymous function that is passed a string, and this time it is returning the reverse of that string. So once I pass hello to this lambda function, it will return the reverse. Great. And this is another example. Over here I am passing a list to this lambda function. So this list, learning is fun with Arif, having 1 2 3 4 5 string is passed over here, and it is returning the length. So over here, once you will check out, you will find the length of this string, length of this list, 1 2 3 4 and 5. Well, my dear students, these baby examples were just to make you comfortable with defining of lambda functions. The real usage of lambda function is actually passing them as arguments to other functions like map, filter and reduce, and we will soon reach to this topic as well. Okay, so let's see how we can use lambda function and pass them to other functions. Over here we have a simple piece of code. We have a function myadd, mysub and mymul that are passed two arguments, and they return the sum, difference and product of these two numbers. And over here we have called these three functions. This is just a piece of cake. So 8 plus 2 is 10, 8 minus 2 is 6, and 8 into 2 is 16. Great. We can write above three functions over here, myadd, mysub and mymul, as lambda functions. So this lambda function is passed two arguments, and it has an expression which returns the sum, and the address of this lambda function is there in the identifier myadd. And similarly, we have two more lambda functions. Now let us write a calculator function over here like this. This function is passed the two arguments as well as a function, an operation which is going to decide whether this calculator program is going to add these two numbers, subtract them or multiply them. And over here you can see my calculator is passed myadd. This will return the sum. My calculator is passed mysub, and it is going to return the subtraction of these two values. Let me run this, and let me run this and this. So we have got the result. Now a more elegant way of writing the above code is something like this. We use the myCalculator function, and instead of writing the name, we write down the lambda function over here. So this is a lambda function which is passed two arguments, and this is the expression, the plus operation which will be performed on two arguments and will be returned. And these two arguments are basically 8 and 2 over here. So this is how we use lambda functions inside a function which is passed a function as an argument. Okay, with this background, let's move ahead and see how we can use a lambda function as argument to the built-in map function. So before we do that, let's understand what the map function do. The map function is passed normally two arguments, a function and an iterable, maybe more, and it simply returns a map object. after applying this function to all the elements of this iterable. And of course, later we can typecast that map object to appropriate data structure. And remember, the original iterable or iterables remains unchanged. Do get help about the map function, read that. And let me tell you this with an example. Okay. So in this example, we have a list of numbers, and suppose we want to create a new list in which every element is the square of this. That is, I want to generate a list having a 25 and a 49 and a 4 and a 36 and so on. So one way of doing it, that I have created an empty list and then I have entered into a loop. This probably we have done before as well. I have entered in a loop, and for every item in this list, I am just doing what? I am appending the item power 2 to this empty list. So once this loop will be over, this empty list, my list underscore squared, will contain the squares of each element of this list. Great. So we can do this thing with the map function as well. And for that we need to pass an appropriate regular function as its first argument. We will pass a function over here which will of course get the square of the numbers of every iterable over here. And you see we have used the map function. We have defined a function square of our own, which is passed a single value, and it calculates the power of 2 for that value and returns it. So what this map function is going to do, it is going to pass every item of this list to this function, and whatever value is returned from that function, it is going to create a corresponding map object for that. And later we can always typecast it to appropriate data structure. So you see we have received a new list, created a new list containing the square of all the items over here. And here is how we can use the lambda function instead of creating a regular function as shown over here. Instead of using this, I am just writing down an anonymous function over here that is performing the same job. So this is the list. I'm calling map and I'm passing it a lambda function over here, which is receiving one argument from this list and computing its square. The second argument from this list, computing its square. The third argument from this list, computing its square, and returning a map object. And I'm going to typecast it to a list and I will get the result. My dear students, I have tried to do it step by step so that you should understand how we can use the map function and how we can pass a regular function to this map function and how we can use the lambda function instead. Let's see another example. Suppose we have a list and we want to create another list based on the elements of this list, and the new list should have elements which are the values, which are the remainders which we can get after dividing each element by 5. So we will divide 74 by 5 and we will get 4, the remainder. We will divide 85 by 5 and we will get 0, the remainder, and so on. And this is the appropriate lambda function that is passed to this map. Remember the behavior of map. Every item of this iterable is passed to this list, is passed to this lambda function. It will compute a value, and for all the values of this list, it will return a map object. We typecast it to list and we get the result. So the remainder of 74 divided by 5 is 4. The remainder of 85 divided by 5 is 0, and so on. Let's see another example. Suppose we have two lists, my list 1 and my list 2, containing these numbers, and suppose that I want to add the contents of these two lists and create another list. So over here I am passing two iterables to this map function. For every element of this and this list, this lambda function is going to add those two numbers and the next two numbers and the next two corresponding numbers, and finally will return a map object, and we will typecast it to list, and we will get the resulting list which contains the sum of each corresponding element of these two lists. Okay, so another example. Over here we have a list of names, 1, 2, 3, 4, 4 names, and I want to generate another list that has the length of each of these strings. So this is the lambda function. Over here note that every item of this list, suppose for the very first time Mujahid will be passed to this lambda function. Mujahid will come in A. This function, the length function, will be passed Mujahid and it will return 1, 2, 3, 4, 5, 6, 7, 7, the length of Mujahid. And finally we will have a list containing the length of each of these names. Great. I hope with so much examples this makes sense to you all. Okay, after the map function, let's move on to the filter function. Before we use lambda function as argument to this filter function, let's understand what this filter function actually do. My dear students, filter function is passed a function and an iterable. It provides a convenient way to filter out all the elements of this iterable for which this function returns true. And if this function is not passed, it is none. All the elements of this iterable that itself are true will be returned. The filter object returned by this filter function contains only those items of this iterables for which this function returns true. Remember, and of course the original iterable remains unchanged. And finally, you can of course typecast that filter object to a list. Let's see this in this example. And before I discuss this, remember I have talked this before as well. In Python, these objects are considered false, none and false itself. The numeric type 0, 0.0 and the complex 0j. And empty sequences like empty string, empty tuple, empty list, empty directory, an empty set, and a range object of 0. So over here I am having a list having these values. I'm calling the filter function and I'm not passing any function to it. I'm not passing this function, so we have a none over here, and this is the my list. So the filter function will return all those items or elements from this list which are actually true, and we see that 5 is true, minus 3 is true, this true is true, this 9 is true, and this 8 is true. Great. And remember, this filter object returns this filter function returns a filter object, and we have typecasted it to list. So this is what the filter function do. Let's see another example. So we have a list of numbers, and let's suppose that we just want to extract even numbers from this list. So over here I am using a lambda function. You see how simple it is. So this is a lambda function which will be passed every items of this list numbers. First 1 will be passed, 1 mod 2 double equals 0. So this is false, so it will not be returned into the resulting list. And for 4 mod 2 double equals 0, so that is true. So this 4 will be placed in the side of the list. So finally, once this will run, we will have 4, 6, 8 and 12 in the resulting list. So a very powerful function, filter. We mostly use it in data science. Let's see another example. Let's suppose this is a list again, and we just want to extract negative numbers. So this is the lambda function that is going to extract negative numbers from this list. Great. Another example. Suppose we have a list containing characters, and I just want to extract vowels from this list. For that, I have created another list that is vowels, and inside the lambda function I am just checking out that whether each character which is passed to this lambda function one after another that exists in this list of vowels. If true, then it will be placed in the result. I, A, and E. So these are the three vowels over here. Great. Okay, after this filter, let's move on to reduce. My dear students, reduce work differently than map and filter. Actually, it does not return a new iterable based on the function and iterable we pass to it. Instead, it returns a single value. And this is a signature of reduce. It is passed a function, a sequence, and maybe an optional initial value. Let's suppose that the sequence is 47, 11, 42, and 13. Once we call a reduce on this, what will happen is this function will be applied to the first two arguments 47 and 11. Let's suppose this is a sum function, so these will be sum. We have for 58. After that, this function is again applied to this resulting value and the next value in the iterable 42 plus 58, we get 100. And to this, again this function is applied to this result with the next value of the iterable, that is 100 plus 13, which is 113. So this is what a reduce function do. It actually reduce as per this function. It reduce the sequence of elements which are passed over here to a single value as per the operation that is mentioned inside this function. And if you pass this optional initial value, which is by default 0, so it will be placed before this iterable. So if we pass, let's suppose 5 over here, so first of all this 5 will be added to 47 and then the resulting value will be added with 11 and so on. Let's understand this with an example. Let's suppose we have a list of numbers, and let me do it first with help of a loop. So we declare a variable total is equal to 0, which will contain the sum, and I will run a loop for every number in this list numbers. What I'm going to do is I'm going to add that number to the total, and finally I'm going to output it. Great. So this is 113. The same. Great. Okay, let's use reduce. If you want to use reduce, my dear students, you have to add this module from func tools import reduce. We will talk about modules in detail in our future session. For the time being, just remember that if you want to use reduce, you have to write down this line, this import line. And what this reduce function is going to do, it is going to take this iterable numbers and it is going to call my add on every two numbers of this list. So first it will add 47 and 11, then the resulting value will be again passed with the value of 42, and then the resulting value will be again passed with the next value 13, and finally this reduce function will return a single value that will be the sum of all the elements in this list. Okay, so over here I have used a reduce and I have passed a regular function to reduce. Let's use the lambda function instead. So this is again very simple. If you have understood the definition of the creation of the lambda functions above, this lambda function is passed two arguments and it returns the sum. And here is the iterable. So this will again produce the same result. And for completeness, let me tell you how this initial parameter works. This is the same code as above. This is the lambda function that performs the summation of two values. This is the iterable numbers, and over here I am passing a third argument to this reduce function, which is 10. So in the very beginning this 10 will be added with 47, the resulting value will be added with 11, the resulting value will be added with 42 and 13, and you will get the result which will be this time 1, 2, 3. Okay, hope this is clear. Let's see some other examples for better understanding. Let's suppose we have a list over here and we just want the product of all these numbers. So here is the lambda function that I'm passing to reduce. The expression, note the expression, this is x into y. So this is the product of all the numbers inside this list. Let's see another example. Let's suppose I want to find the minimum or maybe the maximum numbers from this list. Note the lambda function this time. It says that this lambda function is going to be passed two numbers from this list, AB, and it will return A if A is less than B, otherwise it will return B. So it will return a single value. And every time it will compare 1 and 2, it will return 1, then 1 and 3, it will return 1, 1 and 4, it will return 1, 1 and 5, it will return 1. And similarly, we can write a lambda function that will compute the max. Do make changes to the values of this list and check out what you get as the result. Okay, so let me run it again. So you get the minimum number as 4 and the maximum as 93. Okay, so two more examples. Over here we are just checking out whether this lambda function over here, this is going to check out whether all the values in this iterable are true. Suppose this is an iterable containing these values and we have seen that all the values are not true. So how it will work is it will pass these two values A and B and it will perform a AND, logical AND, returns 0 and so on, and finally you know the result will be of course 0 or false. And of course if you want to check out that if any of the value in this iterable is true, you will use the OR operator over here. Okay, anyway, so let's move ahead and see the sorted function now. I think that we have discussed this sorted function while we were discussing the session of tuples. So let's understand this in the context of lambda functions now. So let me recall that the sorted is a built-in Python built-in function that is passed an iterable, and it sorts that iterable. And by default, it sorts it in ascending order. And if you want to do it in descending order, you pass this reverse argument a true value. And what we are interested right now is the key argument. And this is the key argument to which we pass a function. And this function is actually used to perform a customized sort. So let's see this example. Consider a tuple of strings A, B, C, Z, X, Y, Z, A, and so on. If we pass this tuple to this sorted function, it will sort the list alphabetically. So it is very simple and straight. So this A, B, C, Z, A will come first, and then this Arif will come, and then this B will come, and then this X will come. Suppose we want to sort this list by the last character. So for that, I just want that it should be sorted something like this, that X, Y, Z, A being the last character should come first, then this Arif, then B, A, S, and then A, B, C, Z. And this is very simple. We pass the key argument to the sorted function, and we pass a function to the key argument, and the function is this, and this function receives every item of the iterable and returns the last character. So the sorted function is passed this function last. Every item of this iterable is passed to this function, and a shadow list will be generated, which will be containing the characters Z, A, S, and F. And based on that shadow list, this sorted function is going to sort. So you see, now we have the sorting based on the last character. And I think this is the example, excuse me, which we discussed in the session of tuples as well. So let's see the use of lambda functions. Yes, over here I have used the lambda function instead. So instead of defining this function as a regular function last, I'm using the lambda function, and see the simplicity. Every item of this iterable is passed to this lambda function, and it will return its last character. So this string is passed, abcz is passed to this, and it will return z, and xyz a is passed and will return a. And based on that shadow list, this sorted function is going to sort this tuple. Okay, so I hope this makes sense now. This is how we can use lambda functions to sorted function. Let's see another example. Let's suppose we have this list, and this list contains elements. Each element is a tuple of two values. If we call this sorted function on this list, it will by default sort this list based on the first value of the tuple. So we will get 125 in the very beginning and 98 at the very end. 125 in the beginning and 98 at the very end. What if we want to sort it by based on the second element of each tuple? I mean to say that I want to sort it on the second element. That means this 9 comma 8 should come first, and then this 6 comma 15, then this value of 25, and then 30. So I have written a function for this. This sorted function is passed this function. For every item of this list, this function will be called, and this function will return the second item. When the first tuple is called 4 comma 30, this will return 30. When the next tuple is passed to this function, it will return 15, then 25, and then 8. And based on that shadow list, this sorting will be done. So finally, the resulting list will have a sorted tuple, sorted list having tuples based on the second values instead of the first. So you see this 8 is here, then we have 15, then 25, and then 30. And of course, we can use lambda function instead of just a named function passing to the key parameter. And this is the lambda function. You see the simplicity. Over here we have defined a separate regular function, and over here we are just using the lambda function. Every tuple of this list, every element of this list is passed to this lambda function, and it is going to return the second element, or the element at index 1. At index 0 we have 4, and at index 1 we have 30. So we will have a shadow list, and based on that shadow list, this sorted function is going to sort. Great. Okay, so a bonus. Let's talk about some new things I just want to add on. First is the zip function. This zip function is passed multiple iterables, and it returns an iterator of tuples, where ith tuple contains the ith element from each of the arguments passed. So in simple words, let's suppose we have two lists, x and y, having same number of elements. I pass these two lists or these two iterables to this zip function. This will return a zip object. I will typecast it to list, and I will have the list of 1, 4, 2, 5, 3, 6. So I will have a list having tuples, or tuples of 2. And if I want to zip 3 iterables, 3 lists, I can do that as well. I hope this makes sense. This zip function is simply zipping each corresponding element. And remember, over here as well we have same number of elements in all the list. In case if you have more or less number of elements in a list, the iterator normally stops when the shortest input iterable is exhausted. So we have 1, 4, 2, 5, 3, 6. This 7 and 8 will not be accommodated in the resulting list. And in case if you have a single iterable, it returns a list each having a tuple of one element. And with no arguments, uh, that is, we don't pass an argument to this zip, you get an empty iterator. Great. Okay, my dear students, let's talk about iterators and generators now. In the very end, we have seen iterators in our previous session of for loops. We discussed the concept of iterator object, which is used to iterate over iterables like list and tuples. Remember, we have a list over here having three elements. We pass this list to the iter function. So you can pass a list, you can pass a tuple to it. And this iter function is going to return an iterator for this iterable object. Let me repeat again. This iter function is passed an iterable, and this iter function is going to return an iterator for this iterable object. So this is a list iterator. And later on, remember, we have used the next function, which is passed this iterator object that we have received from this iter function. And each time we pass this next function to this iterator object, it will return the next item of this iterator. So we will get all the three items. And after that, if I call next again, of course, it will return an error. Let me do next again. So it will say stop iteration. This is how the for loops work. Okay, let's talk about the generators now. My dear students, a generator is a function that can send back a value and then later resume its execution from where it left off. A generator function allows us to generate a sequence of values over time. This is a function whose name is myGenerator, and instead of using the return statement, it is using a yield statement, and this is what this function becomes a generator. Once you call a generator function the way we have called it over here, it is not that its name is generator function, the name can be anything, but this is a generator function because we are using the yield keyword over here. Once we call this generator function, it don't actually return a value and then exit. Rather, it automatically suspend and resume its execution later on. So for the first time when I will call this generator function, it will give me the generator object. Oops. Okay, so I have to execute this cell first and then this. Okay, it will return me a generator object, and then when I will call the next, it will give me this portion till this yield. This generator function has not executed completely. It has just executed this part and returned 10. If I call it again, it will return the next item. And if I call it again, it will return the next item. Remember, this generator function is different from this iter function. This returns an iterator. This generates the list all at a time. Whether there are 1 million elements over here, it generates the list and return. However, this generator function is different. It generates something till this point. Then once it is called again, it generates something till this point. Then once it is called again, it generates something till this point. So finally, once I call the generator function again, it will of course give the stop iteration error. So this was just a hello world to understand the difference between an iterator and generator. Oh well, writing a generator function that returns cubes of numbers. Suppose this is a function with the name generate cubes. It is passed number n, and there is a loop for num in range n. What it is going to do, it is going to yield the cube of the number which is passed. So over here I am calling this, let me do this. Okay, I am calling this generator this time. I am not calling a iterator function. I am calling a generator function. So this generator function will generate these values one after another. So it appears that they have gone in a simple go, but this will execute the body of the loop, then will call again, execute the body of the loop, then it will call again. The main advantage of using a generator function over the iterator function is that elements are generated dynamically. Since the next item is generated only after the first is consumed. So it is more memory efficient than the iterator. Okay, so do check your concept by reading all this. I have intentionally skipped this decorators. My dear students, decorator is another category that can be thought of as function which modify the functionality of another function. So do make time and search for the decorators and see if you can write down codes for this. And that is it. My dear students, this was really an important session. Uh, the concepts that we discussed today in this notebook are a must to understand for all those who see their future in the data science domain. Do lot and lot of practice to have a crystal clear understanding of all the concepts. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best, happy learning, and Allah Hafiz.